connection check error. Taking the screws out, and you can just move the top back without having to take the ribbon cable out. And this one does have fuses, but only 3, not 4. There's 3 on that side and 3 on this side. And with the meter, I can check the fuses, see if they're blown. These are fine, and that's channel 1. But the channel 2, which doesn't work, if we put just check the fuses here. They're blown. We know the fuses are blown, but are any of the FETs blown? Normally, with the fuses, you get away with protecting the FETs. I've taken the top off just so I can check the FETs over. You have to remove the one end of the ribbon cable. These can vary the way they're clamped, but these ones just flick up. It's very difficult to put it back on, and these are quite easily damaged, these tiny little silver contacts, when you're trying to put it back into there. And then you have to make sure it's fully in and push down the clamp. To make it a bit easier, you can get a much longer ribbon, which makes it very easy to do. Just make sure you get the right one, and make sure you don't damage the ends when you're putting them in, and clamp it down. Make sure you put it in the right way round as well. In this case, the blue is this side up, and as you can see in this one, the blue is that side up. Don't put it in the other way round, it won't work. So that's that. I've shown before on videos, it's very easy to check all the FETs in here, which often blow when you get faults. Now this is a 308, which means it's only rated at 30 amps output and can take up to 8S. And for that reason, they've only got 3 15 amp fuses in here for 45 amps maximum. The 406, which is 40 amps for instance, would have 4 of these, which is 60 amps. Anyway, these 3 are blown. It's not highly critical how many of these fuses you put in, 3 or 4. And in fact, I'm going to replace them with slightly bigger ones, these ones, which are much easier to fit, and because the pad is extended from there to there, they will fit. And these are rated at 30 amps each, which means I've only got to put 2 in rather than fiddle around with putting these 15 amp ones, which is the highest fuse value you can get with these little ones. So you have to put 3 or 4, whereas these bigger ones are a bit easier to solder, and you only need to put 2 in. Sometimes there are fuses on the input up here as well, but this one hasn't got them. Anyway, the FETs, there's a row of FETs on this side and a row on this side for each channel. It's pretty symmetrical, though some are reversed the way they've been clamped in. And I know where all the connections are, but you can find them, or you can take the heatsink off by undoing all these screws, dropping it off, and you can see them and measure them on the other side. But I know where they are. There's 3 connections on each, 3 there, and there's 3 there, 3 connections, 3 connections, and there's also one on the input. And as I've shown you before, it's easy to do. I use an analog meter. It's very easy to see with an analog meter what you're doing. You connect from the outside connection on the FET there to the middle one, and you get a reading. It says about 70, and on the other edge about 500. Go to the other side. This is the blown side, to check that. Same connections, 70 and about 500. So that one's good. If it's blown, it will give no reading at all, or a short circuit right over here. And you can work your way through them. As I say, some of these are the other way around, so that one is that way, and the one on the other side is that way and that way. That's fine. I've been through all them all, and all the FETs are fine, so he hasn't blown any of them. So it's just the fuse. I'm going to swap those fuses out, test it. I normally current limit the input just in case, with either power supply with current limiting, or you can buy power supply limiters, which you can limit the voltage input and the current output, so that if this has got a short circuit you don't blow your power supply or burn anything out. They're quite nice. You can get them all different sizes and shapes, and go in a box. This one's not actually in a box, but it would be nice in a box. Just going to solder the fuses in. I've shown before, if you haven't got a very good soldering iron or have difficulty, you can solder the new fuses on top of the old ones, because they just got connections front and rear and they're all connected in parallel. If you can, got a decent soldering iron or whatever, you can unsolder them and take them out without damaging the pads. Replace the fuses with two of the bigger ones. Just make sure they're okay. They connect to the negative input, so they go all the way through, and to that FET as well. The FET is still good. Just in case you overheat the fuses and damage them, you might as well check them before you put it back together again. Checking the operation after repairing. I've got a battery connected. This is the channel that wasn't working. I've got current limiting on there if necessary. But it's showing the battery voltage, the two battery voltages. Let's see if it charges. 4 amps, so it might see the current rising on there as well. The current on there slightly less because it's a power input and it's got 12 volts, and this is only 8 volts, so it draws only 3 amps and delivers 4. It's working. Check the discharge function as well. Well, that's working okay as well. It's finished then. Just screw the back on and that'll be fine. 2 more iChargers to fix, both 406 duos. This one, I can smell it. It smells burnt, so obviously something's happened. This one, they said smoke came out of it, so if they smell the circuit board's obviously burnt or something's burnt, and it's going to be very obvious what it is. And this one is an older one. There's no fuses anywhere, which means if you get a fault, it normally blows the FETs out. So I'm just going to take the heatsink off, and it'll be easy to look at the FETs on the other side. Take the screws out, the heatsink just pulls off. These are insulation pads which you have to put back on afterwards, so you can peel them off. You put them back on afterwards. Now the FETs, when they're blown, they're normally black and horrible. There's a black mark on that one, definitely, and you can see black around it where it's blown out. So that one's definitely gone. I can check the others after we've cut that one out. I'll cut it out, leaving the legs, and solder another one. Cut away the legs, and there's a big burnt patch on the circuit board, and the FET itself got a big burnt hole in the front. I can actually see what make it is under a microscope. It's the IRF32 on the front. The rest is burned away, but I know it's an IRF3205. I've got a lot of data here on FETs that you can use in here. 3205, it's 55 volts, 8 milliohms, 110 amps. You can get better ones than that if you want, looking around, and this is a good one, the 3306, 60 volts, 120 to 160 amps, higher current, better voltage. And if you're not going to put a lot of voltage through here, say 40 volts max, you can use this one, the 40190R. That's rated at 190 amps at 40 volts, so it's even better. And this one also is very good, the 3034, 195 amps at 40 volts, and that is the most powerful one, I think. So if you're not going to put more than 40 volts on the input, you can use that. If you want to use the one they've used, it's 55 volt rated. That's a 3205. But any of these, as long as they're high current, the higher the current the better. So I'm sure I've got one of these. And I've done other videos too. These legs have been a bit burnt, but as long as you've got the 3 legs sticking up, you can position the new FET in position. You cut the legs short, don't snap them off by bending them close to the case, but just a little bend. And as long as it's flat, you can solder them on. I'll do that in a minute, and make sure it's flat so that the heatsink fits flat across all of them. I tested all the others to make sure that they were fine using this meter. I've been through all of them, that's the only one that was burnt out. This iCharger, I've replaced that blown FET there, but there is another fault with it, and it's this resistor, surface mount resistor, 6.8 ohms, is open circuit. It comes from this chip, which obviously drives the FET on and off. So changing the surface mount resistor is a bit cause a little, well, it's quite difficult, well, for me anyway, but I've got a 6.8 ohm resistor. I'm going to solder it across. This one's actually open circuit. I don't know why it's blown, whether it must have blown out when this blew out, or who knows. Let's hope the chip's alright anyway. I've soldered a resistor in place of that blown 6.8. I only had a 10 ohm, and that's the only one I had, but I've soldered it across, and now you can see that both sides of the FETs now read the same. If you look at the meter, now this one reads correctly as well. So hopefully it's going to be okay. We'll test it out. Put it back together. Just checking this channel 1 first. Reading all those. So we stop that. -2, so we know the discharge works on that channel as well. Connected to the right hand channel. Let's just see, showing both voltages, and the discharge is working as well. Oh, looks like success. So at least means all the control circuits working on both sides, charging and discharging. The only odd thing about this one was having to replace that resistor, that tiny surface mount resistor from the control chip, 6.8 ohms. I put a 10 ohm in, and the FET of course was blown to Kingdom Come. I think it was, this one was blown to pieces. So another iCharger back working. This iCharger is completely dead, and it's one of the ones that has some fuses on the input between the positive and to this rail here. You can hardly see them at all. I'll try and zoom in. They're just right underneath this red wire. There's 2 of them rated at 25 amps each, side by side. Very difficult to replace. You've got 2 options. Forget it and just put a shorting link across, and or I use some slightly bigger ones. They're very small, these, and just solder them from this giant pad across, one on each side. I've done that before. If it was my own, I'd forget the fuses and just put a bridging thing. But why have they blown? Well, I've shown you before with the meter how you can easily check all these FETs. It's normally always the fuses or the FETs that blow in these things. Occasionally I've seen these capacitors all swollen up, but not lately. And as I've shown you before, you just, these three legs, if you know where all the FETs are, there's about 4 or 5 on each side, and there's one in the middle too, which is the power one. You just got to know which way to connect across the leads. It's one way or the other, depending on which way they've been soldered in. And you get a reading from one leg to the middle. See that just under 70, and the other one it's just over 500, and they're symmetrical, so you can check the other side as well. And now up here, this one up here, if I just connect across it, short circuit. So the one in that corner, I've been through them all, is blown. And funny enough, it often blows. It was the one that was blown in the other one I just repaired earlier. And that has blown out, and it's taken the fuse at the same time. I don't know what they were doing to blow it out. Discharging, I think. They're N-channel, high power. You need about 100 amp. And the voltage would depend on what voltage you're going to run it at. If you're not only doing 2S, you can put 40 volt ones. If you're doing 6S or 8S, if this is I think this goes up to 8S, you'll probably need a 55 volt or 60 volt if you're going to do an 8S. Most people don't do 8S, so you can use a slightly lower voltage one. But anyway, an FET and the fuses. Taking the heatsink off, exposing all the FETs. The heatsink, normally you get burning black marks on these if they're burnt out, but this one hasn't. But it was, now we turned it over, it's this one up here, and I can just show you on the meter again. So this one on the other side, it's same orientation as you can see. It should be showing like that and like that. 70 and about 150. Not dead short. The fuses were blown, and this power goes through this one here, and so you'd expect that possibly to have blown as well, but it's fine, which is good. And I've checked all the others and they're alright, so it's just that one up there. I've cut out the blown FET. There it is. It's not blown apart. Normally they're blown apart and solder blown outside, a bit of the case blown off. This one hasn't. So we can read the number on it, 3205, which is pretty typical. The 3205 is this one here, 55 volts, 110 amps. I normally replace it, if we're going to keep the voltage rating, with this one, the 3306. It's 60 volts, 120 amps, and the on resistance is very good. Look, it's about 3.3 to 4.2 max, and this is at 8 milliohms. So it's much better FET. There's hardly any difference in the cost. It's the same size and everything. So I've got one of them here. And what I do is carefully bend the legs, not right against the case. If you bend them against the case, you can fracture them. So you put and it's got to go down that way. So bend them the correct way, which is down. Just put a little curve on them so they don't fracture. And then the next very important thing to do is you've got to cut them off flush with the top of this, otherwise it won't fit flush down, and you're going to solder them against the 3 sticking up, because when I took that off I used some very fine side cutters and cut them off, leaving the legs sticking up. Cut them flush, put them on there, and they're going to solder up against the original pins that are sticking up. So it's going to be nice and flat when you put this back on. It's going to be the same height. Solder the FET back into position. Before screwing it back together, you might as well check, make sure that everything's fine. and there's not some other problem somewhere. No, it's given the right readings now. And also you can make sure that it's pretty much flush with the others, flush along here, so when you put the heatsink on, it contacts all of them and one's not pushed up too high or something. This one here, it's just got some heatsink compound just to transfer the heat. It doesn't have to be insulated from this heatsink. All these have got heatsinks as well. If these fall off, just make sure you put them back on. So I've got to decide what to do about the fuse. The fuses from the positive, which I think is that one, to these rails, but on the other side, this big conducting part here, they're the fuses in there. I've got some fuses I use. I've got some 30 amp fuses here, physically bigger. These are tiny, they're like these little ones. They're like these. They're very difficult to solder in or get out, but these I put two before in a pattern from one side, and you can solder one to the other side as well. It is possible. You can't you try unsoldering that red wire, that is difficult to get off without making everything so hot. So you've got two choices: try and put some fuses in, or forget the fuses. The fuses didn't protect that FET, it blew out anyway. These fuses are 30 amp. There I also choose medium blow. I don't like the ultra fast blow ones. They're supposed to protect the electronics. I find they don't. They blow out much easier. Medium blow can take a little bit of a transient before they blow, so I decided to put some heavy duty wire bridging from the positive using some of this thick piece of copper wire, tin, 16 gauge. I've just run it round that thin part in the middle has to carry a lot of current either to the left or the right, so I've gone round the thin part and then onto the positive. Replaced the blown FET and shorted out the input fuses. I've got a current limit here just in case. I plugged it in, switched it on, see if it's working, so nothing else is wrong. It's recording the voltages on this channel, so let's see if it charges. Side by side that was blown, so let's see if it works. So the charging side's working on both sides. I've just got to do the discharge. So it's working. And that's the discharge path going through there, through all those FETs all the way around, and then we can do it around the other way. Just got to swap these over. Discharging from this channel through into the load. So both channels are working on high current discharge. I'll just double check them on high current charge, and then that one's finished. Another iCharger to repair. Looks like a 308 Duo with some custom graphics on it. Quite nice. One thing I noticed with this one is this button doesn't seem to work. These work. You can hear it beeping. That one works. This one works. This one works. Does this one work? Probably because the ribbon cable is not seated properly. Oh, so I've got to take it apart to look at that. The buttons weren't working properly. I can see just by looking that the lower ribbon cable connector is not in straight. It's hanging out one side, which means it hasn't got any connections. So I'm going, the top one seems okay. It's just this bottom one down here. So I've got to just get that back in. It's very short and you have to be very careful. Reseated that cable. Now you can hear All the buttons are working now. I did find capacitor here. The protective or insulating sleeves come off. It's actually stuck or hanging off the roof there. I don't know if you can see that. Well, this can is normally not connected to anything on these, but it could short if it moved against something and then something else. It could short it out. So I'll just put a little bit of protective. I'll put a little bit of protective sleeve on that. Otherwise, everything else inside looks clean. Thin bit of plastic sleeving should do the trick. I'll just slide it in. Just slid it in underneath and just wraps around so it's not going to vibrate or be knocked against anything and short it out. And the other bit's still in the top that I wrap around the top of it and I screw it back together. Anyway, all the buttons working properly, but I'll just do one final check. I'll do a regenerative discharge through the resistor box, 30 amps. 30 amps discharge. These buttons all work. Let's just get it back to the customer.